In this module, we will talk about the mass transport. As mass transport, we understand the flow of particles or mass within the system. Until now, our focus has been on time-dependent chemical reactions in homogeneous systems. In these systems, the concentration of species is uniform throughout and the mass transport processes are absent. However, mass transport processes are also part of system dynamics, even in the absence of chemical reactions. Mass transport is expressed by a physical quantity known as the flux of particles J. Flux, denoted as J, is defined as the amount of particles transferred across a given area over time. To illustrate flux, consider a container filled with gas particles. In equilibrium, these particles are expected to be evenly distributed, maintaining a uniform particle density throughout the container. However, if the particle density becomes greater on one side of the container than the other, the system is no longer in equilibrium. The gas particles will naturally move from the area of higher density to the area of lower density. Going into more details, flux is a vector quantity. Its magnitude reflects the flow's intensity and is equal to the number of particles crossing from one side of the partition to the other side per unit of area and time. Its direction indicates the direction in which the particles are moving. In this example, the flux vector points from the higher density side to the lower density side. Flux is a local property that varies from point to point within a system. This is particularly important in systems where the properties of the medium, like gas density or temperature, or external forces like electromagnetic fields, vary across the system. In such cases, the flux at different points in the system can have different magnitudes and directions, reflecting the local conditions. Mass transport can be categorized into several types, each with distinct mechanisms and implications. Here is a brief overview. Diffusion is the movement of particles from an area of higher concentration to an area of lower concentration. It is a result of the random motion of particles and occurs in various systems, including gases, liquids, and solids. Diffusion is a fundamental process in numerous physical, biological, and chemical systems. Convection involves the movement of molecules within fluids, liquids, or gases caused by mechanical forces. It can be due to external factors such as steering, shaking, or rotating. Convection is crucial in various processes, including heat transfer, mixing of substances, and in natural phenomena like weather patterns. Migration refers to the movement of ions due to an electric field gradient. It's a key process in electrochemistry, including applications such as electrolysis.